Welcome to section 5.2, Integration by Substitution. Our goal today is to find indefinite integrals using general indefinite integral formulas. Some of the formulas we're looking at today are very similar to what we looked at in our last section, but in these cases, now we're dealing with functions instead of expressions. So if we have a function raised to a power, the integral of that would be similar to the integral of an expression raised to a power. In this case, we have f of x raised to n plus 1 over the n plus 1 plus c. Our second one is e raised to a function. These are all very similar, like I said, to what we've seen in the last section. In these cases, we're going to have to keep in mind that we're doing the chain rule in reverse. Some of the ones that may seem a little newer are 4, 5, and 6, where we have u to the n du, the integral of e to the u, and the integral of 1 over u du. Again, we're using substitution, so these ones are going to be very handy for us if we need to substitute something in place of u. Some important definitions for today are differentials. If y equals f of x defines a differentiable function, then the differential dx of the independent variable x is an arbitrary real number. And the differential dy of the dependent variable y is the product of f prime and dx. So for example, dy equals f prime of x dx. That's the product we're talking about. The procedure we're going to use today is select a substitution that will simplify the integrand. In particular, try to select u so du is a factor. Express it entirely in terms of u and du, eliminating the original variable and its differential. Evaluate the new integral, and then express it in its original variables. Let's do a few so that way you can see how it works and how to use those formulas that we talked about. In problems 1 through 8, find each indefinite integral and check the result by differentiating. Here we have the integral of 5x cubed plus 7x squared minus 5, all raised to the 4th power, times 15x squared plus 14x dx. So now we can see, okay, I don't just have an expression, I have my whole function raised to a power now. Let's start by defining what we want u to be and du. So remember, du is going to be the derivative of u. So if you see something that could be u and something that can be the derivative of it, that's going to work best in your favor. Here, if I make 5x cubed plus 7x squared minus 5 my u value, if I take the derivative of that and I get 15x squared plus 14x, well, I can see u is right here and du is right here. So that's going to be our best option. In this case, since we took the derivative, I also need to put dx. Now, I can, let's see, let me clean this up a minute. I can represent this part as u to the 4th power and this part as du. And so we can rewrite this in terms of only u, and we won't have x or dx. So now we have the integral of u to the 4th du. Let's take the integral. So we have u to the 5th over 5 plus c. And the last step is going to be substituting back in what we had for u. So I'm going to pull that 1/5 out front and put back in u. We said was 5x cubed plus 7x squared minus 5 raised to that 5th power plus c. Okay, now I'm going to do a second step and I'm going to check it to make sure that we're on the right track. So if y equals 1/5 times 5x cubed plus 7x squared minus 5 to the 5th power plus c, if we take the derivative, dy dx, then we'll have 1/5 times, we do the power rule, 5 times 5x cubed plus 7x squared minus 5 to the 4th. Then we have to do the chain rule and take the derivative of the inside. So we have 15x squared plus 14x. And if we clean that up a little, we can 5 divided by 5, so we're left with 5x cubed plus 7x squared minus 5 to the 4th times 15x squared plus 14x. And that's where we started, so it checks out. Okay, the integral of the 4th root of 5x to the 5th minus 7x plus 3 times 25x to the 4th minus 7. Let's start by substituting u and du. So here, I'm going to substitute u as 5x to the 5th minus 7x plus 3, and du would be the derivative of that, so 25x to the 4th minus 7 dx. Luckily, I see that here I have the 4th root of u, and here I have du. So it's completely substituted. So let's rewrite it. Integral of u to the 1/4 du. If we take the integral, then we'll have u to the 5/4 over 5/4 plus c. Now we substitute u back in, so we'll have, let's see here, x to the 5th minus 7x plus 3 to the 5/4 plus c. And the last thing I'm going to do is put it back in radical form. So we have that 4/5 with the 4th root of 5x to the 5th minus 7x plus 3 to the 5th plus c. Now let's check. If y equals 4/5 times 5x to the 5th minus 7x plus 3 to the 5/4 plus c, the derivative dy dx will be 4/5. We'll do our power rule, so we have 5/4 times the inside to a 1/4 power. Chain rule, we take the derivative of the inside, so we have 25x to the 4th minus 7. And this cleans up to be 4th root of 5x to the 5th minus 7x plus 3 times 25x to the 4th minus 7. And that's what we started with, so it looks good. Okay. The integral of 3t cubed plus 4 over 6t to the 4th plus 32t minus 7 dt. Let's make our substitution. U and du. So, in this case, it looks like I'll start with u being 6t to the 4th plus 32t minus 7. So du will be 24t cubed plus 32 dt. Now, from what we see, our denominator is u, but our numerator is not du. So I'm going to rewrite my du as 8 times 3t. I'm going to factor out an 8 basically, because by doing that, now it looks more like what we had before. We have 8 du here. So, because there are 8 du, I'm going to have to divide that 8 out when I'm substituting in the u values. This is going to be rewritten as, we'll have 1/8, dividing that 8 out, and we have 1 over u du, because remember, we have 8 times what we have, the 3t cubed, 8 du. We really only need 1 du. So we're dividing the 8 out. Now we can take the integral. So we'll have 1/8. The integral of 1 over u is natural log of u plus c. And then we'll substitute back in. We have natural log. U is 6t to the 4th plus 32t minus 7. So for 8 plus c. We'll check it. If y equals natural log 6t to the 4th plus 32t minus 7 all over 8 plus c. We take the derivative, dy dt. We'll have 1 over 8 times everything inside, 6t to the 4th plus 32t minus 7. And then chain rule, derivative of the inside. So we have 24t cubed plus 32. And so dy dt is, the 8 divides out, so we're left with 3t to the 4th plus 4 over 6t to the fourth. We have t to the third. Plus 32t minus 7. And that is where we started. Okay, so we're doing all right. Okay. The integral of e to the negative 1.5x dx. So let's start by making u that exponent. Negative 1.5x makes du negative 1.5 dx. Now in this case, I'm going to solve for my dx because all I have here is e to the u and then I have dx. But on what we've solved for du, we have negative 1.5 dx. So what I'm going to do is take one more step and find out what is dx in this case, and it's du over negative 1.5. So that's what we're going to be substituting into the dx value. So we'll rewrite this as e to the u, and then we have du dividing by that negative 1.5. So to make this look a little bit cleaner, we'll have 1 over negative 1.5 integral of e to the u du. Now if we divide 1 divided by 1.5, this is just going to be 2/3. So that's what I'm going to be writing. And now we have it all in terms of u. So we can take our integral. We'll have negative 2/3. The integral of e to the u is e to the u plus c. And so we'll substitute back in. U was negative 1.5x plus c. Let's check it. So y equals negative 2/3 e to the negative 1.5x plus c. If we take the derivative, we'll have negative 2/3 e to the negative 1.5x. It's itself. Chain rule, derivative of negative 1.5x, so negative 1.5. Now we've got negative 1.5 times negative 2/3. So we will be left with e to the negative 1.5x. And that's what we started with, so we should be feeling pretty good. Okay, integral of x times x plus 7 to the 7th dx. Let's start by substituting what's inside the parentheses. U equals x plus 7. And that will make it easier to take the integral because we'll have u to the 7th. So this, if we take the derivative, du equals dx. Now, we can see we'll have u to the 7th, du is dx, but we have this x here. So I'm going to use kind of a similar tactic as the last example. I'm going to rewrite what we call u in terms of x to find out what can I substitute in for x. So x is going to give me u minus 7. And that's what we're going to plug in here. So we have u minus 7, u to the 7th du that we're looking at. And before we do anything, I'm going to distribute the u. So we have u to the 8th minus 7u to the 7th du. Now we can take the integral. So the integral of u to the 8th will be u to the 9th over 9 minus 7 u to the 7th. The integral will be u to the 8th over 8 plus c. And now we have to substitute u back in. So we have x plus 7 to the 9th over 9 minus 7 x plus 7 to the 8th over 8 plus c. Let's check it. If y equals x plus 7 to the 9th over 9 minus 7 x plus 7 to the 8th over 8 plus c, we take the derivative, dy dx. Then the derivative of the first, we'll have that 1/9. I'll pull the 1/9 out. Now we do the power rule, so we have 9 times x plus 7 to the 8th. Chain rule, derivative of x plus 7 is just going to give us 1. Then we have 7 over 8 times, bring the power rule, 8 x plus 7 to the 7th, chain rule times 1. So now we've got 9 over 9, 8 over 8. This is going to give us x plus 7 to the 8th minus 7 x plus 7 to the 7th and what we can do in this situation is we can factor out x plus 7 so if I pull an x plus 7 to the 7th power out of each of these, then I'll have an x plus 7 left from the 8th power minus the 7 in front of the 7th power. And we can rewrite this one more time as x plus 7 to the 7th times just x, because 7 minus 7 is 0. And that takes us back to where we started. The trickiest part on this one was knowing that I can factor out an x plus 7. Okay, integral of 2 times the natural log of 3x squared, all raised to the 4th, over x. So, let's see, the most inside function is going to be the natural log of 3x squared. Let's make u the natural log of 3x squared. That way it can be u to the 4th power. Du becomes, let's see, 1 over 3x squared times 6x dx. So that's going to give us 6x over 3x squared dx. And we can reduce that to be 2 over x dx. Okay, so just making sure we see everything we have here. U to the fourth, and then here we have du. So that looks like we've covered it all. So this becomes the integral of u to the fourth du. Taking the integral, we have u to the fifth over 5 plus c. Substituting back in, we have natural log of 3x squared to the fifth over 5 plus c. And that's going to be it. We'll check it. So if y equals natural log of 3x squared all to the fifth over 5 plus c, the derivative dy dx will give us, we'll pull the 1/5 power rule, 5 times the natural log of 3x squared to the fourth power, chain rule, so we have that 6x over 3x squared. And then we clean it up a little, we'll have, we said that was 2 over x, so we have 2 natural log 3x squared to the fourth over x. And that takes us back to the beginning. Very good. Okay. The integral of 1 over x to the 6th times e to the negative 1 over x to the 5th dx. So let's do u is negative x to the negative 5. Let's take care of that exponent so that way we have e to the u. Then du, we take the derivative, we'll have 5x to the negative 6 dx. So this is going to give us, I can see the x to the negative 6, I can see dx. We have an extra 5 here, so the only thing we'll have to do is divide out that 5. So 1/5 integral, I have u, I have du. So we've got e to the u du, all represented here. Taking the integral, 1/5, e to the u is just e to the u plus c. And let's substitute back in. So we'll have 1/5 e to the negative 1 over x to the 5th plus c. We'll check. If y equals 1/5 e to the 1 over x to the 5th, it's a negative, plus c, then we take the derivative, dy dx will give us 1/5 e to the negative 1 over x to the 5. Chain rule, we'll have 5x to the negative 6. So dy dx will be e to the negative 1 over x to the 5th, 5s over x to the 6th. There we go. Okay. dy dx equals 12x squared times 2x cubed plus 7 all to the 5th. So the first thing I'm going to do is multiply both sides by dx. So that way we've got dy equals 12x squared times 2x cubed plus 7 to the 5th dx. And now we can take the integral. So we'll let u be what's inside, so that way it'll just be u to the 5th. 2x cubed plus 7. So du will be 6x dx. 6x squared, actually, dx. And we can see that we've got here u to the 5th. Here we have 2 du. So when we rewrite, we will be writing it as the integral of 2u to the 5th du. Taking the integral, we'll have 2u to the 6th over 6 plus c. So, plugging back in, I'll reduce that 1/3. U is 2x cubed plus 7 to the 6th plus c. Let's check it. If y equals 1/3 2x cubed plus 7 to the 6th plus c, and we take the derivative, dy dx, then we'll get 1/3, use the power rule, 6 times 2x cubed plus 7 to the 5th, chain rule, 6x squared. And this cleans up to be 12x squared times 2x cubed plus 7 to the 5th. There we go. Okay, the indefinite integral can be found in more than one way. Given the integral 2x times x squared plus 3 squared dx, first use the substitution method to find the indefinite integral, and then find it without using substitution. Okay. Substitution. We'll start by letting u equal that x squared plus 3. That way we have u squared. Du would be 2x. And that takes care of everything. So if we rewrite it, we'll have the integral of u squared du. That will give us u cubed over 3 plus c. And so, since u is x squared plus 3, that's cubed over 3 plus c. Now what we can do with this one is really expand it out. So this can be rewritten as 1/3 x squared plus 3 cubed plus c. And when you cube that, we'll get x to the 6th over 3 plus 3x to the fourth plus 9x squared plus c. Okay. Now, if we want to do it without substitution, then I'm going to start by multiplying at the beginning. So we have 2x times x squared plus 3 squared. And I'm going to start by squaring x squared plus 3. So we'll have x to the fourth plus 6x squared plus 9. And then if we distribute, we'll have 2x to the fifth plus 12x cubed plus 18x. So now if we take the integral of that, 2x to the fifth plus 12x cubed plus 18x dx, then we'll have the integral of x to the fifth will be x to the sixth over 6, 12x to the fourth over 4, 18x squared over 2 plus c. And so we can clean that up and it'll be x to the sixth over 3 plus 3x to the fourth plus 9x squared plus c. And thankfully they are both the same. So this is just an example showing you can do it with or without substitution in some cases.